Hi, welcome to my channel mathssl. Please show love and support. I'm speaking Mr. Thaqib Latif. I'm going to show you question 3 regarding a similarity. Similar triangle, remember we're proving here a similar triangle. This is our theorem, and then we doing the question about this theorem. Now this question 3 says AB is a tangent and to the circle at B, and C is a tangent to the circle at C. AC parallel to BE. So AC parallel to BE, and AB, this is AB, is a tangent, and then CE. CE is also a tangent. So first question says, prove that triangle ABC is similar to triangle CDB. Have a look. So we need to prove here that the triangle ABC, which is this one, and the second triangle CDB, CDB, which is this one. Very important question, this one, CDB. Now, so these two triangles we need to prove they are similar. So must remember ABC and CDB. Have a look. So we're going to start now. So triangle ABC, that's how you're going to write, and triangle CDB. A go with C, angle A with C. So if I start look angle A with angle C, so this is angle A, this is angle C, right? So I don't want to waste the time here. Rather, I can see if I can find easy angle. So first I'm gonna go with that because I need a two angle, and the third one automatically gonna be third angle of triangle. Have a look. So I jump to now angle B and D with B and D. So angle B is here and D is here. So now angle B2 is gonna be equal to angle D1. Why? Because tan chord theorem. Because angle between tan and chord, this AB is a tangent and the BC is a chord, right? And where is gonna form the angle? B and C by the D1. So tan chord theorem. So angle B2 is gonna be equal to angle D1. And the reason is tan chord theorem. Now, have a look. We need one more angle. So this we have one. I need more. So now I must go for C and B. C and B. Right. So angle C and B. If I look here, this is a transversal line. These two parallel lines. So the angle C3 is going to be equal to angle B1. Alternative angle. C3 equal to B1. Alternative angle. So angle C3 is equal to angle B1, alternative angles, and we're using two line parallel, which is AC parallel to BE. It's my second angle, and obviously I told you the third angle. Now angle A is going to be angle C equal to angle C2. That's gonna be angle A is equal to angle C2, a third angle of triangle. But remember the last one, even you know you don't need to write, you just two two angle we need. So the third one automatically gonna be third angle of triangle. Now therefore triangle ABC is similar to triangle CDB. The reason is angle, angle, angle. So this is my first question. Remember the question says triangle ABC must have to prove similar to triangle CDB. So which means these two triangles already exist in the sketch. Alright. So you can follow this sequence, this pattern. A go with C, B go with D, C go with B. That's why at the last you can say therefore triangle ABC similar to triangle CDB. But in next lesson I'm going to teach you uh, where you need to first identify the triangle and then you have to prove. So that's why it's very important. So if you can also write like this BCA and then you have to follow the pattern DBC. You cannot do this side, you decide BCA and then you decide CBD is wrong. Look here. So triangle BCA similar to triangle CDB. This is wrong. Why? Because B, have a look here, B with D. So how can you make B with C? Is wrong this one. Can you see what I mean? So that's why you have to follow the pattern. So if you choose here BCA, then it's also going to be this side DBC. But these triangle exist already in the sketch. That's why we choose ABC, CDB, because A go with the C and B with the D, there's B with the D, and C with the B, and there's C with B. The second says CD times BC is equal to AB times BD. Now, this type of question always we need to find the proportions first, proportion sides. So the AB is over CD. First two equal to last two BC and then last two DB. A and C first and third and then C and B. AC, CB, first, third. So the reason is similar triangles. Now I need to see which one I'm gonna use here. So I have CD times BC. So where is the CD? CD I have here, BC I have here. So they are locked. So these two I'm gonna use. So the AB over CD is equal to AC over CB. Cross multiply. This becomes AB times BC. Sorry, he asked CD and BC. CD and BC. So CD is here, BC is here. So if you time with both these CD and BC, BC times CD is going to be this. These two we're going to use, not this one. Sorry for this, not this one. Mistake. So we're going to use AB over CD is equal to BC over DB. Cross multiply is AB times BD is equal to BC times CD. So we prove. You see that you can write either way. AB times BD is equal to CD times BC, or you can write according to this. Same thing. So we're gonna do now triangle CDE must prove parallel similar to triangle BCE. So CDE is this one and BCE is the major one, big one. So we need to prove these two triangles are similar. So triangle So third one, triangle CDE and the triangle BCE. So C go with B. So have a look. This is angle C with the angle B. So remember, CD is also a CE is a tangent. C is a tangent. So tan, and this is a chord. Angle between tan and chord. This is a chord. This is the tan, and this is the angle between tan and chord. So where is forming the angle in alternative segment? Have a look. The angle B1. So which means angle C1 is going to be equal to angle B1. The reason is tan chord theorem. Now, so D go with the C. Now, I don't want to waste the time. I can see CDE and BCE. This is a common angle. You're going to use a lot also this reason, because if you find easy way out, why must you go through difficulty? So the angle E, have a look. Angle E, the common angle between these both triangles. They're going to find a lot of these type of questions. So angle E is equal to angle E. The reason is common. This is my first angle, second and two angle. You find the last one is going to be third angle of triangle. So the angle D2 I left only. This side, angle D2 now. So the angle D2 is going to be equal to angle C1 plus C2. Why? Because remember BCE, these both angles. This is the third angle of the triangle for BCE. So the angle D2 is going to be equal to angle C1 plus angle C2 and the third angle of triangle. Therefore, triangle CDE similar to triangle BCE. The reason is angle, angle, angle. The fourth one say BC times C is equal to CD times BE. Remember, I have to make proportions. So now in this case, CD go with BC. CD with BC. So CD, number 4, we're going to start. CD over BC. And then DE over CE. And now C first and third letter, CE. And this is also first and third letter, BE over BE. So we reason gives similar triangles. Now I need to see which one I'm going to use. BC times CE. Which one I'm going to make BC times CE? So BC times CE. BC times CE. Both cross multiply. So which means this one and this one. These two we're going to use. So CD over BC is going to be equal to CE over BE. Cross multiply. So it's going to be how he wanted. You can write like this: BC times CE. BC times CE is equal to, he wants CD times BE, CD times BE, CD times BE. Even you can write another way also. If you can also do this one: CD times BE this side and BC times CE that side, doesn't matter. So this is the part 4. The part 5, they say BC over CE is equal to AC times BE, BD over CD times BE. This type of question, remember we used to do trig identities. So information is wherever, if the information is left hand side is more, then we utilize that side. If the information is more on right hand side, we utilize right hand side. In this case, we have more information on right hand side, so I'm going to utilize this side, right hand side. So I'm looking AC O time BD is a numerator on top, the denominator CD time BD. So have a look AC and BD, where do you have, or you still need to find. So start from the first question, part one we already found. So the part one we already have here, AB and CD, BC, DB, AC and CB. So we're looking where is we need BC over DB. So the uh, AC and BD. So the AC is here and time DB is this two. Can you see? AC time DB. In this one, we're gonna use this. We're going to use this one and this one, right? Uh, because AC time DB, we need on top AC time DB. So these two. So we say part 5. So we're gonna use BC over DB is equal to AC over CB from, so BC over DB. So the BC over DB is equal to AC over CB from 2. Remember, from 2. These two we take it from 2, these two. And now cross multiply here. You're going to cross multiply. So it's going to be BC time CB and equal to AC time DB. Now, remember, this is, I can say BC square also, but the requirements is not BC square, because I can write x time x square. I can write x time x, or I can write x square, same thing. So requirement is this. This one is the requirement, BC time BC. We don't need a square. So I isolate BC here. So it's gonna be AC time DB over C. So BC is equal to AC time DB over CB. So that's, I isolate BC from here. So the BC's become equal to AC time DB over CB. Now we need the denominator, CD time BE. Have a look where you're gonna find out that one. CD time BE is nothing here, and you come to have a look here. CD and BE we have here. Can you see from 4? So we can use this. So we say CD, this 4, CD BC CE BE. CD over BC is equal to CE over BE from 4. Now cross multiply also. You don't need to show these arrows, only for your understanding. I'm showing you now here. So it's gonna be BC times CE is equal to these two. You can add first this one or this one, doesn't matter. CD times BE. Right. So we're gonna isolate again BC here. So the BC is gonna be CD times BE over CE. Now this BC is equal to AC time DB over CB. This BC equal to CD time B over CE. So both they are equal to BC. So this both side is we can equate because both they are equal to, which means they are both equal to BC, so which means these both sides they are equal. So the AC times DB over CB is equal to CD times BE over CE. Now, obviously, we again have to cross multiply here. So it's going to be AC times DB times CE. Must remember requirement of the question. You go with that, right? The requirement of the question is, so BC must be left hand side must be isolated. So we only working numerator and denominator. Automatically you're gonna come this. That's why we take out BC first because we BC we need on left hand side. So that's why we isolate BC. So when we isolate BC, we come with these two equation here. So one is this AC and DB over CB, and the other side is this one. These two. These two must remember, na? These two. So they're both equal to BC. That's why we equate. So now this is gonna be CD times BE times with the CB. Now, so according to the question, you need CDBE must be at the bottom. So CDBE we have this side. So we divide by CD and BE both side. Cancel, only BC left here. I can pull this side, and that's which means AC times DB times CE over CD times BE. Now you see, I can do one time because CE also must be at the bottom. I can time all of these one time. I can divide, sorry, CD, BE, and CE. But I first do this, then I can do this one because sometimes you don't know if you need this one or not. But in this case, we need all three. So CD, BE, and CE. You can divide all at once, or you can one by one. Now I have to divide CE also, but divide by both sides. So if you divide by CE both sides, so this is gonna be divided by BC divided by CE, and this side is gonna be AC times DB over CD times BE because you divide by CE and cancel. So therefore, BC over CE, AC times DB over CD times BE, we prove this one. I hope so you like my video. Please subscribe and like and comments on my video. Have a nice day.